Hi friends, welcome back to my channel Skillset Go. In the previous video we have seen what is deterministic finite automata in a compiler. So the compiler uses the finite automata to parse the tokens in a lexical analysis phase. So in this video we will see what is indeterministic finite automata and what is the difference between deterministic finite automata and indeterministic finite automata. So this is a deterministic finite automata example. So it has 5 parts, finite number of states. So these are the states. An initial state, this is the initial state, a final state which represents like this, and input string where we will match the pattern, and the transition state where we need to go from one state to other state. So in indeterministic finite automata also we will have a same parts and same states, but if you observe this DFA diagram, every input character, suppose from this state, for the input character 1, it will go to only one state. So from here if it is 1, it will go to again same state. From here if it is 0, then it will go to state 2 always. But in indeterministic automata, suppose from this state on the character 1, it can go to a different states. It may go to S2 or it may go to any other state. So let's take a small example for the indeterministic finite automata. Let's take a similar diagram. From the state 1, if the character is 0, then it will go to same state. And from state 1, if the character is 0 or 1, it will go to S2. And here, if it is 1, it will go to final state. And from final state, if we have again 1, then it will come to state 2. So this is the example of indeterministic finite automata. If we observe the difference between indeterministic and deterministic finite automata, here from this state, if we get a character 0, then which state it will go? If you see, it can go to same state or it can go to a different state. So it is indeterministic. From the same character, it is going to 2 states, state 1 again and state 2. So this is the main difference between deterministic automata and indeterministic finite automata. Let's take a same string as input and try to match the pattern. So let's take first character 1. So from this state, if it is 1, it must go to state 2. So presently it is in state 2. Let's take the next character 1. From this state, if it is 1, then it must go to a state 3, which is a final state. Then the next character is 0, 1. So if it is 0, again it will go to S3. So it will stay on the same state. So again if it is 1, if you see from the state S3, if it is a 1, it may go to same state or it can go to S2. So presently it is in S3, again it can go to same state or it can go to S2. Here if you see, there are 2 possibilities. This is the main difference between deterministic finite automata and indeterministic finite automata. In deterministic finite automata, we don't get these type of diagrams, these type of options. It must go to either only single state. So presently the state is in S3 and S2. So let's take next character 0. So from S3 if it is 0, then again it needs to go to S3. From S2 if it is 0, it cannot go to anywhere. So this path closes. Now it is in S3. If it is 0, again it will stay on the same state, and the last character is 1. It may go to same state S3 and it may go to S2. So here the character token ends. So finally the string is in these 2 states. If you see, S3 is final state and S3 is not. So one of the state is a final state. So this one is a valid token. So let's take an invalid token example. Suppose if a string is like this, 0 0 0 1 0. So let's try to match this pattern. Let's take first character 0. So from this state, if it is 0, it may go to same state or it may go to S2. So presently it is in S1 and S2. Again the next character is 0. From S1, if it is 0, again we have two options, either 0, either S1 or S2. So again we have S1, S2. So from S2, if it is 0, then there is no path, then this path closes. Then next, take the next character 0. Again from S1 we have two paths, S1 and S2. It can go to S1, it can go to S2. From S2, if it is 0, then there is no path, it closes. Then take the next character 1. Presently the state is in S1 and S2. So from S1, if it is 1, then it must go to S2. So there is only one option. From S2, if it is 1, then it will go to S3. So let's take the last character, which is 0. So we have two states, S2, S3. If it is 0, then from S2 we don't have a path. But for S3 we have a path to the S3 again. So this is the final state after completion of this number, and this state is a final state, which is the accepted state. So this string is also a valid string for this diagram. Let's see any number which will invalidate. Suppose if the number is just like this, 0, 0, 0. So it has only 3 zeros. Then it cannot move forward from this state. If you see this diagram, to S3 we can reach only if the number has a 1. If the input string doesn't have a character 1, then we cannot go to final state. So we can easily say this one is a invalid token for this indeterministic finite automata. So these two tokens are valid, but this one is invalid because we don't have any 1 here. So indirectly we can't reach this final state. If you see, we can reach final state only if we have number 1. So I hope you understood the main difference between deterministic finite automata and indeterministic finite automata. The main difference is only this point. It can reach a different number of states based on the same character input. But in deterministic automata, we will reach only one state based on one character. So please like, share and subscribe my channel for more videos, and thank you for watching.